It is indeed a great pleasure, great pleasure to be here. And why I wanted to come so strongly here. I'm becoming mystical. But I will not speak of this topic. But one reason is that in Princeton, I had a great fortune to interact almost for 1 year with Kurt Gödel. This was a fantastic experience. I learned more from him, or equivalent, than what I heard at the university in Princeton for many years. I wanted to come here because he was born near here, Brno, or close by. And maybe tonight at dinner I will say a few things about my interaction with him. But I am so much dreaming, and Orge knows that. We are all dreaming. And maybe there is even a deeper reason which makes the discussion with Gödel very actual. I will tell you maybe at dinner time. But it's interesting. Because contrary to what people could have imagined, Gödel was absolutely up to date on all the scientific literature. And I enjoy discussing with him because he knew also the physics very deeply inside the horizon of a Kerr metric. You understand what I'm saying? He was not isolated. He was up to date on the Kerr metric, on the inner part of the Kerr metric. Today, we are working practically only on the Kerr metric, which I will try to convince you. On the Kerr metric, but different Kerr metric, outside. A Kerr metric which is not the one that you find in Misner-Thorne-Wheeler. The uniqueness of the Kerr metric, which has been debate philosophically, the uniqueness. Sorry for being, I need to convey something that, and quickly, because we don't have much time. The black hole, the concept of black hole, was introduced discussing with John Wheeler. And distinctively at a meeting, he was speaking, he said, in New York, he said, why we don't put courage, the name black hole? And then we wrote this fantastic article. It was a pleasure to write with him, because he was able to capture what the topic were and express beautifully. Even today, this is one of the most beautiful articles written. But the ground, again, was the Kerr metric. We just apply an effective potential technique that Wheeler had found in a book of a Norwegian who had studied the trajectory of the solar, of the night sky in the, and this trajectory he applied to the he suggested to apply to the Kerr-Mated effective potential. And the concept of ergosphere came out. And Lifshitz was so excited that he dedicated an exercise in Landau-Lifshitz to our solution with Wheeler of the 42% binding of the co-rotating, counter-rotating. I was always very, very happy about that work of the effective potential. And even a few years ago, 2 years ago, we had a festivity. I will not tell you now, because I would like to tell you of this great adventure. We were said that we went after the Crawford Award of Roy to Cambridge, and we wanted to meet someone, at least Martin Rees. And then we asked Martin, can we see Stephen? No, he's under hospital. And then they called, the secretary came and said, oh, we were so sorry with Roy. So well, at least to say hello to him. And even in the hospital. And then secretary came and said, no, excuse me, but Professor Hawking would like to see you in the hospital. Let's rush. He said, no, he's downstairs. We had a fantastic interaction. And then he said, Remo, can you give a talk? Of course I can give a talk. And from that talk, I remember only in front of him to show him the slides. That was a special race. The paper in 1970, September 17, 1970, my paper with Dimitrios on March 1st, 71, the paper by Stephen on March 11, and there was the mass formula. It was a neck to neck. And the talk was beautiful, and then he said after that, but Remo, what about dinner? Dinner? I said, yes, and then invite us to dinner. It was fantastic. Believe me, it was one of the best dinners in my life. I'm not joking. Now, this formula has been sitting there. Extract energy. How you can extract energy? Books have been written. You agree? Books. Many books. Many textbooks. The uniqueness was the problem. What's wrong? The idea. You cannot extract from a uniqueness, a black hole respecting the uniqueness theorem, you cannot extract any energy by definition. I hope you understand this. Something dramatic is happening. In January 14 of this year, 3 fantastic telescopes Fermi, Niels Gerald Swift. I have a better image if I change, but let's not lose time. TeV radiation was observed from one of the most spectacular gamma ray bursts ever observed. 1901-14C. For the first time, we understand all the gamma ray bursts, all of it. My colleague will be more calm, but show you something more. But this is the message I want to give. And as soon as we practice magic with Orge and our group. We look at the gamma ray burst. We wait until the redshift is obtained. Within, with the data, we trigger Swift, or trigger, in the case of this Swift, trigger Fermi. Okay, one data. We wait until the redshift is determined. We know that it's a BDHN. And then we send the GCN out, and we said, look, since you have seen this redshift and this energy, because you know the energy now, this is a binary-driven hypernova. And if you look carefully in 18 days, in the same spot, you will see the supernova rising. GCN, all the world informed. Nobody believed, of course. But exactly after 18 days and so forth, as we predicted, there the supernova popped out. Ah, magic. We did first another case with Org 1304A. 0427A. We practice on 13. But 13 had a problem. The data were not perfect. They were piled up. Was not ideal. But it worked. And said, oh, you are lucky. No, no, no. It's a BDHN. You follow up to here? Okay? How many BDHN they are? Binary-driven hypernova. There are 329. There are binary-driven hypernova of family 1, 2, 3, and 4. And then, of course, there are short GRB with neutron star merge, neutron star white dwarf, and so forth. But we have plenty, 329. What is a binary-driven hypernova? I hope to do, let me go fast, because all the work I did was necessary to understand this system 1901-14C. And what was the work which I did before? I worked, of course, with Riccardo Giacconi on the binary X-ray sources. We published a beautiful book with Riccardo. I don't know if you know the book. SENX3, Cygnus X1. This was the background we did for 20 years. Hercules, all this system that you are looking in the QPO, well, we studied them with Ricardo. But was necessary. And somebody in New York told me one day, but you have SenX3, what will happen? And stupid Remo answered, well, one day the companion star will evolve and make a supernova and accrete on the neutron star. And then I said to the public, everybody laughed, said, but we need to wait for 10 million years. We don't have that time. Stupid Remo. Stupid Remo. We don't have to wait 10 million years or 10, no, we don't need to wait. And the solution were the gamma ray burst. Because you can see all over the universe. Is clear? And therefore you find one that after 10 million years of evolution from SenX3, explode the supernova and accretes. And that is the binary-driven hypernova. Is clear? Therefore, this background of the binary was essential. When the companion neutron star in SenX3, or now we are really waiting a system even more complicated. Maybe we have one in the last 4 or 5 days we have found. Like Cygnus X1. What happens when the companion of Cygnus X1 goes supernova? It will be different from this. It's the BDHN number 4. We have an example. Is that clear? I hope. Therefore, when the second supernova accretes on the companion, but I have to go fast, then you have that the expansion of the supernova on the companion either form a black hole or form another neutron star. And all this, I don't want to give a lecture on this, please. The key point is, if the accretion is strong enough of the supernova and the neutron star nearby is only a period of 4 minutes, the accretion is so big on the neutron star that it collapses to a black hole. We see for the first time this event. We see it in 1901 14C. We have seen it. It took quite a lot of effort. We see the moment of formation of the black hole. Tomorrow you will have a lot of examples. Okay, this is the sequence. You have the supernova exploding. This is after 3.8 seconds. There you have the black is the neutron star. After 7.7 seconds, you have the neutron star inside the supernova. After 254 seconds, you have the formation of the black hole. And then it keeps going. Everything lasts for 300 seconds. But it's a laboratory. It's a laboratory. All this has been understood. You want to see? Oh, there has been a change of paradigm. which we have done in our group. A profound, of course, we have the first profound difference is that we had the good chance of collaborating with Los Alamos and make this beautiful picture. Laura Becerra, student of Orge, did this fantastic work. You should enjoy looking at it. Here you have the supernova explosion accreting on the companion neutron star and on the new neutron star, and has been temporarily evolved. You see, this is after 406 seconds. This is after 120 seconds. We have, because people said, can we have a picture? Of course, we cannot take a picture because this object exploded 10 billion years ago. But we can, on the computer, reproduce, retrace completely the system. These are pictures, like if it was real. But let me go now to something more close to us. This picture. Okay, let me just, I don't know if I have all the, let me go to explain this picture. What has been the difference? The profound difference between us and everybody else. The profound difference has been that a gamma ray burst lasts of the order of 100 seconds. 100 seconds, for a common astronomer, is nothing. I mean, an astronomer looks for centuries. No, I mean, it's 100 seconds. It's nothing. I mean, it's nothing. 100 seconds. And the philosophy was of the common astrophysicist, well, let's make a spectrum out of 100 seconds. The band function. And they made band function on this 100 seconds. Nothing came out. Our group approached a different philosophy. Let's look not to all the gamma ray bursts. No. Let's look just to the very powerful gamma ray burst. And finally, 1901-14C has been one which is powerful enough. This one. And then you make a spectral analysis wherever you have enough photon to make a spectral analysis. You don't impose the time. You just make the spectral analysis as detailed as possible on the shortest possible time scale. Instead of integrating, make a spectral analysis, time resolved. And when the spectral analysis time resolved is made, this is what comes out. You have here the trigger. Here you have this first emission. This is our supernova which explode. Then you have up to 1/19 second. Then you have 2 seconds, here, 2 seconds, where 75% of the energy of the gamma ray burst is emitted. And then here you have a cavity. You have a third event after 10 seconds. But as soon as the supernova, following the binary-driven hypernova concept, I hope you follow this. As soon as the supernova secreted enough matter, the black hole is formed. Therefore, after this first event, which is the supernova, tac, the black hole is born, the JEV emission starts. The JEV emission is the most fantastic thing, in my opinion, in the universe. Because it's giving a new understanding of the physics that your group and our group are pioneering, are the JEV radiation, this radiation. Can forget everything else. This is the key. Now, you have 2 seconds. You have 2 seconds. Okay. First, let's look at the supernova. And this is the fantastic work. We took him with us. Liang Li has done. The spectrum of the supernova. We have a spectrum. It's a supernova which lasts for, quick. How much lasts the supernova?
0. About 1 second.
1 second. The supernova appearance, 1 second. And then, you have 2 seconds. Okay. Then you have the explosion of the GRB, and then after the explosion of the GRB, you have, this is published finally, is in print, you have the cavity. We have the theory of the cavity made. When the explosion happens, after the GRB has exploded, you have a cavity formed. Now, okay, let me give you this other concept which is crucial. I cannot give many concepts. You follow up to this, you have a companion star which has exploded, has formed a black hole inside the star. It forms a cavity. We have computed. We have made a model, it's in press in RPJ. But what is the greatest result? Now be careful. We can compute the average density of matter in that cavity. Is 10 minus 14 gram cc. We have, for the first time, observed the birth of the black hole. It has formed a cavity. The cavity is 10 minus 14 grams cc. And there you see the JEV emission. You follow the logic? Therefore, we are in the beginning of a new era. I was speaking with Roger Blanford last week, 2 weeks ago. I said, Roger, we have to have a courage to let this, but we have to do together to let know the scientific community that high density accretion does not exist. All the stable orbit of my work is not applied to this system. This system are tiny density of energy. It will take some years to people to appreciate this. These systems are not accreting gravitationally. They are not. Therefore, the last stable orbit, the mass, different. Okay, this is as much as I can give you at the moment. But let me give you another information. Let's see if I have at least the slides. So, otherwise, I will be forced to change. Okay, The key point is that we see everything now. We see the supernova, we see the UPE, the cavity. Okay, this is the one of.
This is 15 of 427.
Yes. We have studied the beauty of the machine. You will hear a lot about, but I want to find another one, if you don't mind. I have to make at least a jump. Va bene? Ce la facciamo? Ok. This is a new. Sì, quella. Lì ci dovevano essere gli altri, va bene? Sì, sì, facciamo vedere quella, dall'inizio. Quickly, 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 quickly. Yes, that one. Go on. Okay, here you see the same picture before, but a little better. Ah, beautiful. Here you see more beautiful. Here you see more beautiful. Okay, go on. Here the super. This you have seen. Now, a deep question, which we are working on, why nature has built a gamma ray burst. The gamma ray burst is by far, the most complex system in the universe, by far. Why? The message is, okay, maybe I will come back to this, but let me show you what happened. What happened, and this is the work of Liang Li. Of course, he was guided to obtain this. Here you have the 1901-14C. Here you have the J radiation. And then I told him, why we don't look better these 2 seconds where there is 75% of the energy? 75% of the energy is only in 2 seconds. Why we don't look better? And the spectra was obtained, and the spectra is cutoff power law plus a black body. 2 seconds. 10 to the 35 ergs emitted. Cutoff power law plus black body. And then I asked him, well, why you don't take 1 second and then another second, divide by 2? And he came back, he said, there are still a cutoff power law, a black body. Then I told him, well, divide by 4. Okay, you will have a paper on this, you will have all the time. By 4. It's always cutoff power law plus black body. Then divide by 8 until you have photons. It's still the same. This is a new field. In these 2 seconds, there is self-similarity. Self-similarity is something which cannot be explained by the blast wave going a gamma 100,000. No, this is a discrete system. It's discrete. Clear this point? It's a discrete system. And it keeps going to be discrete. It's not a continuous. When you look at that 2 seconds and you have the luminosity, yes, it's a line. But if you make a spectral analysis, it's a discrete system. In my opinion, this is one of the greatest revolutions. And we have been starting working on this. But then, how can people believe? How can people believe? I say, okay, you have been lucky. You have found a system which you cannot understand what is going on. Okay, so what? Good. But what is that good for? I mean, you found one. Then I said, let's not publish. Let's not publish. He's still here, and he has been working on the plane. If you don't put the line, the straight, there is a little difference. A few, to me, is important. They are out of alignment. This one should be aligned with this. He promised to align by tonight. Okay, sure? But anyway, after the supernova, you form the black hole, bah, the J radiation starts. 1901 14C. And then we look at other 3 gamma ray bursts. And here it is, also in the other one. And the fantastic thing is that you see the supernova here, and then you have again the self-similarity. Here it is, the self-similarity. Here it is. And then the J radiation and all that. We have 4 systems now. This is new science. It's the same science that Wilson, Heisenberg when he did the turbulence, Landau when he made the low temperature, Wilson when he did the theory of self-similarity, have managed to do. Okay, now there is another field in which we have been going on, and this is the one which we share with our colleague in here. Can we find a machine? Can we find a machine? Can we find a machine which generates all this? There must be a machine which works at 10 minus 14 grams cc. Ok? Can we find... Ok, mi dai una mano, facciamo vedere soltanto una immagine. Ok, let me put this way, however. This machine generates JEV, TEV, PEV, ultra energy cosmic ray. This is the machine which generates all these cosmic rays. The JEV, the TEV, the PEV, and ultra energy cosmic ray. But if we are over with time, 10 minutes, then I will just show some of the equation, and if we can show maybe the other talk, just to show them the machine, which he will be thrilled. The machine is a Kerr solution, but not a Kerr solution textbook. A Kerr solution textbook, air, no air, and asymptotically flat. Yes, asymptotically flat. Okay, you do a Kerr solution. You cannot do anything with it. Andiamo, se c'è. It's not a Kerr solution. It is, excuse me, it is a Kerr solution. But it's not asymptotically flat. It is not asymptotically flat. Are you following? I hope. This is a revolution, believe me. It's another system.
I don't know why it's in the computer, but
Okay, okay, forget about it. God does not want us to show. It's another solution. Eh? Yes. You have a magnetic field present. Okay, let's forget, because we have 10 minutes, we have no time. But let's go to the incredible science which comes out. Incredible. We know that the system is discrete. We know that the system is discrete. This is the continuous. Go on. We know that, okay. But we must have the way to pay from the mass and the rotation of the black hole all this energy which we see. For the people who have heard the previous talk about the mass of the neutron star and so on, it's fascinating. They were having masses of neutron star around 2 solar masses. Then at around 3 solar masses, you go and form black holes. We have measured the mass and the spin of the black hole. We have measured it. We have measured my mass formula finally has been used. Finally, the formula with Stephen Christodoulou has been used. We can measure the energy extracted and determine the mass and the spin of the black hole. We have a paper written. But the most grandiose result, okay, I show just very quickly. This is the machine. Okay. But there is something grandiose. What is grandiose? Is that this machine does not work continuously. And we knew that was not working continuously because we have seen the cell similarity. Okay? Therefore, we know it's not working continuously because it's cell similar. But now we know the machine which created the cell similarity. And we see that this radiation which is luminosity versus time. Here it is, too smooth. Here, very nice power law. But when you go and see the physics of that line, it's not continuous. It's injected every 10 to the minus 14 seconds. And every 10 minus 14 seconds, the system emits a quantum. And Org and myself wrote a paper about the... Now, be certain that this changed physics completely. Is the quantum black holic, the system works on 10 minus 14 seconds and emit 10 to the 37 ergs per shot. The first time I presented this was in Armenia. There was the ambassador of Germany. I said, Mr. Ambassador, you did not follow anything, but believe me, you as a German, you should be happy. You will be happy because this machine is just like ta 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 ta. It's firing every 10 minutes 14 second energy. Okay, it's okay. I can stop at any time. Now, 5 minutes. I hope you got that. It's impossible to give you more. We can give you, in the next years, to work together, like we have done in Nice, in Pescara, in here, and also we are developing a center in Belarus, and we are propagating down in Kazakhstan, and of course in Armenia and so forth. But my dream is just to develop this Central Europe, and going to Asia in ICRANet in this area. Is essential. But let's dream, because I came here to dream. Why? Why nature has been building this machine? Why? Costs a lot. It must have a very, 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 very important mission. You will not create such a machine all over the universe just for fun. We are dreaming. But today and tonight, maybe I will say a few words about Gödel. One day, John Wheeler knew that I was talking to Kurt Gödel. He did not manage to talk with him. But I found a trick, I will tell you tonight. I found a trick. Incredible. It worked. And we kept discussing for 1 year. And then somebody said, Wheeler said, it will be incredible to tell Gödel all these beautiful things that he does not know about. I did not tell him anything, but I discussed with him. Maybe for the first time, thanks to our work, we are doing now, today, in this town, which must be few kilometers away from where he was born. Where he was born? How many kilometers from here? 50. Okay. And tonight I will tell you some beautiful story about him. But I came here, maybe the reason is that there is even a greater, but we will see. At least now I am dreaming on this. There is even a greater revolution that he was right. Always very soft. Always not like me. Kurt Gödel was very, very, very soft, but very precise. And maybe we have still to have a very important message we are starting to discuss with Org. Therefore, maybe this visit to Opava had a more profound meaning, because everything I am doing lately has a profound meaning, and maybe this is the profound meaning. Thank you for inviting us.
Do you have any questions for
Don't pretend to have understood or that I was good to explain. They were just flashes.
Yeah, I have a historical question because it's certainly a unique chance for us to learn something about the great history of black holes. So you mentioned certainly your seminal paper which produces a reducible mass and which inspired later to introduce the entropy of a black hole. But maybe I'm mistaken, I thought that even Jacob Bekenstein did something before about introduction of entropy before Hawking, or if not, what was the role of Bekenstein? We all know that he also uses.
I thank you, because also this is a good occasion to clarify. Beautiful question, beautiful. And even that question, okay, has a profound meaning. Thank you. Now, don't make me feel too mystical, but this question was important for me to make public statement on this. There is a small book published by Jacob in English and in Italian. And in that book, by the way, every revolution is always made by few people. Okay? We were very few people. We were not necessarily what you call, we were dynamically collaborating. But even in this small number of people, they were different points of view. Okay? Therefore, let's name them. One was Christodoulou. He never appreciated, I gave him a problem, said, look, if you do integrate that equation, of course, Dimitrios was incredible because he never studied in a book, never. He needed mathematics, he developed a field. He never went to the library. There is a university who Chicago tried to get him a professor, but Christodoulou, oh boy, Wald said, but Christodoulou is very weak in mathematics. Of course, Christodoulou invented anytime he needed mathematics. And when I told him, look, this formula must split, please try to integrate, he came back the day after, Remo, you are right, it split. And there is this constant, oh, we have only one choice, to give an Italian name. The irreducible, la massa irriducibile. And we gave the name irreducible mass. And then, let me go a little more. Then, who published this result? Because I gave the idea, Dimitrios made the integration, went to John Wheeler, how do we manage this? I said, no, look, he's 18, I mean, he deserved to be author. But Wheeler said, yes, but we have at least to put the effective potential technique which we invented, and I derived that. And then if you look at the paper, there is author Christodoulou, but there is the equation, the effective potential, John Wheeler and me. Therefore, the editor said, but how can we publish a paper on 3 new results? One is by you and Wheeler. The other by Christodoulou. How can we publish this? And then I said, okay, excuse me, but if we make a declaration signed by John Wheeler and myself that we ask you to publish this by Christodoulou, will you accept? Oh, he said, if you want to do that, yes. I said, yes, because anyway, everybody can read that we did the effective potential. Yes, we do, and we did the letter, and finally Christodoulou get it. Christodoulou was incredible. incredibly in mathematics, not in the physics. He never looked into the irreducible. Now, there were other people around. One was Jacob. Okay? Fantastic person. When you read that book, he said that after the thesis, he had not a very nice word for me and so forth, but let's forget the. He said that at the thesis, there was only one question he could not answer. The one asked by Ruffini. When I read this, I said, but what was my question? And then finally, I understood. In physics, is very, I don't have the possibility to be polite or so. I will tell you exactly what I think. In physics, either you do the physics in the Fermi way. The Fermi way is to look at nature, induce, result. But if in physics, you follow an ideology which is not grounded by experiment, you generate a catastrophe because the system does not converge any longer. There is no way. Therefore, when Wheeler, okay, Christodoulou, Wheeler, Jacob. And Wheeler wrote our paper in a very philosophical way. In fact, the title is Reversible, Irreversible Transformation. Our paper, Wheeler wrote Reversible. And I was always saying, but why the hell you don't do whatever you like, but leave our paper out? Reversible transformation. Of course, it was true. But I was skeptical. And the key point I ask, you can do an analogy with reversible, irreversible transformation. There's no doubt that you can make an analogy in a field using an analogy. But I ask Jacob, can you find an experiment, one, to prove that that is real? I mean, you can, given a field theory, you can make another field theory, okay, by analogy. But it's not clear, it's implemented in nature. This is the point, and he could not answer. My point is still the same, with the enormous difference that finally the real quantization of the black hole and the emission is here. We see the black hole operating at 10 minus 17 seconds, emitting 10 to the 37 Hz. This is physics. Unfortunately, we were still planning to meet with Jacob at the Grossman meeting. A few weeks before, unexpectedly, I did not know he was sick. He died. And it was one of the worst things because we were approaching the point of thing. Okay, so just a moment. The third person who was in the game was a student who was not with me, Christodoulou, not with Johnny Bekenstein, but there was a third person looking over, very, 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 very nice, but not very nice, very molto triste. Always, then I later understood why. I did not know until 2 or 3 years ago that this student who was always very, he had a big problem that his parent, both his parents died in a plane accident when he was 3 years old. I did not know this. And this was Robert Wald. And Robert Wald was looking over the shoulder continuously. I will not go further, but in the thesis of Wald, he introduced the whole solution to prove that you cannot have electromagnetic field like I was speaking on a black hole, because he said it will be very small and negligible. Of course, because he was using a black hole with a magnetic field of few Gauss in interstellar space. Interstellar with density ridiculous. Now we are finally in the condition to show today we are in the condition that this machine can work if you have a field of 10 to the 10 Gauss, and if it works not in a dense medium but very, very weak, and in a black hole which is not of 3 solar mass with A over m very large. Not very large. Quant'è? Quant'è? 0.5. Okay. I hope it's on record. This is really very important, your question, for me, to have said that and to give this as a record. Io sto notando che tutte le cose che io faccio negli ultimi mesi hanno un significato che trascende la mia volontà. E sono affascinato da questo. E già da alcuni mesi avevo trovato Opava così importante da venire. Non avevo la ragione, ma siccome avevo questa necessità e questo intuito, ho accettato con entusiasmo l'invito e ho portato i miei 2 migliori collaboratori. Poi mano a mano ho cominciato a capire qualcosa, ho cominciato a ricordarmi dei miei incontri con Kurt Gödel all'Institute for Advanced Study a Princeton. E ricordavo anche come Kurt Gödel, che era stato richiesto di fare il giuramento di fedeltà alla Costituzione americana, si era presentato assieme a un cittadino americano per diventare residente e cittadino americano, e questo collega americano era Albert Einstein. E nel viaggio da Princeton a Trenton, dove c'era il giudice, in macchina con l'autista, Gödel cominciò a parlare che aveva trovato nella Costituzione americana una falla che poteva mettere in pericolo la democrazia americana. E quando andò a fare il giuramento davanti alla bandiera, con Einstein, testimone, lui continuava a avere questo dubbio e lo manifestò. E quando questo giudice gli disse: "Oh, Professor Gödel, how is fantastic that you are finally coming from Nazi Germany into a democratic country, a real democratic country, and you can wear on the American flag." Gödel said, "Your Highness, al giudice, please allow me to recall that I am not from Nazi Germany. I am from Czechoslovakia. And please allow me to say that the American Constitution has a flaw and his democracy could be put at any moment in danger. The judge closed immediately the process, sent them back to Princeton to study better the American Constitution. After 1 week, the driver brought back Einstein and Gödel to Trenton. This time Einstein asked Gödel, please shut up, just do the vote and forget about. And he did not forget. But today, in the society we are living, maybe Gödel was correct. Therefore, with this in my heart, I start to understand that Opava, within 50 miles from here, there was the birthplace of Kurt Gödel. Therefore, there was a meaning in this visit. And I start to recall the meaning of our meetings. I was one of the first few people to had the privilege in Princeton to discuss with him for more than almost 1 year. Every week we went to a ceremony. Can we meet next week? Oh yes, please call me back on Tuesday. And the telephone was on the telephone book. Then I call on Tuesday. We will call me back on Wednesday afternoon, and then we will decide. Wednesday afternoon, it was always on Friday afternoon at 4 p.m. the meeting. But the way I start, because nobody could approach Gödel. If you approach him on one side, he had developed a technique to turn and not to be approached. He was always with this black hat and the black coat. But I noticed that he was sitting on a small bus that the Institute put at the disposal of the professor to go from the Institute at 12 o'clock to Princeton University. And I noticed he was sitting always in the same place. Therefore, I decided, I sit next to him and forgot about that I needed to I wanted to speak with him. I forgot about. And every day at 12 o'clock myself, he was arriving and I was arriving to go to the university, to my office at the university. Until one day I was just writing the formula and I hear a voice, very strange voice, metallic almost, like the one paradoxically of the synthesizer of Stephen Hawking, something similar, but human, from him, from Kurt Gödel. And he said at a given moment, oh, but this hanging on my notebook is relativity. And I decided, Remo, don't answer. And I said, yes. And then, without looking at him, and then after a few minutes, he started again. Oh, but I have been interested in relativity myself. And with a face of bronze, I said, like if I was the very important professor, if you have anything written, please put in my mailbox. And that was it. The morning after, at 9 o'clock, I went in my mailbox, and there it was, the paper of the rotating universe. that Gödel made a present to Einstein on the 70th birthday. I was incredibly pleased. But let me remind what was the occasion. The 70th birthday of Albert Einstein at the Institute. There were no flags, no banquet. There were no tea, nothing. But there was something very interesting. A lecture by Kurt Gödel at the ground floor of Food Hall, the first room on the left, which you can still go and film that room, which is intact, fortunately. Was a long room with a blackboard. At the blackboard was Kurt Gödel. In the first row, there was only one person, Albert Einstein. All the rest of the room was empty. There were only two people at the last row. One was Martin Schwarzschild. Martin Schwarzschild was professor at Princeton, and he was the son of Karl Schwarzschild, the one who found the first solution of the Einstein equation of a gravitating object, the Schwarzschild solution. The other man who recalled and told me about the meeting was Subramanian Chandrasekhar, who later on got the Nobel Prize. And Einstein told Kurt Gödel, Herrgott, this fantastic way of expressing himself, Herrgott, will not allow you to have that solution. The time went. Every Friday, with the ceremony Monday, Tuesday, Friday afternoon, 4 o'clock, we were meeting. In the paper, there were 10 theorems. I was able to check the first, the second, the third, the fourth, the fifth. By the sixth, it was already very difficult. But at the end, there was the key one, which I could not prove. And therefore, I asked Kurt Gödel, please, can you tell me how you proved the last one? And he smiled and said, oh, I appreciate your point. It took me more than 1 month to prove it. Well, I said, could you maybe look back to your notes and next week, and the following week, I came, he was smiling. It is true. Yes, I said, I understand. He was so happy. I said, yes, but can you write a derivation? Oh, he said. The important point for me was to make sure that it was true. Everything else is a technicality. And he did not tell me anything. But before closing this, let me tell you what to me has been very important. I was interested in that solution, and believe me, in this house, I have a new understanding that maybe Gödel was correct. But let me tell you how I arrived yesterday, to this point. First, one day I asked him, he was in a beautiful, if you go to the Institute, after the library, there is a beautiful room overlooking the pond of the Institute. And there was his office, and had a curtain, very similar, not of black like that, but was a brown curtain down in front of, like this one, but in front of the window. And I asked, but tell me, how you got this idea of a rotating universe? And then, allow me to do that, he started to slide in his chair. And I had, you know, there was an accident in Princeton that one day a German professor went to visit Einstein and in the evening. And a certain moment Einstein said, okay, and then said, I go a moment upstairs, and he left, he went upstairs, and after 1 hour, 2 hours, this German professor went upstairs, and he was sleeping in his bed. And I said, oh boy, maybe he will do, now he's going to take a nap. And he does not answer. And I was not answering. But I was afraid that he would sleep. And then I said, no, but Professor Gödel, I was asking you how you got the idea of a rotating universe. And he was just going down because he was trying to look through the window, under the curtain. And he said, you know, I'm looking. Yes, I'm looking for an object in a universe non-rotating. Was fantastic. Was one sentence. The moon rotates. Everything rotates. And even the galaxy. And in his mind, he was looking through the window to imaginary galaxy, all flattened by rotation. To this, I was absolutely shocked. And I started to think myself about. But another point happened. Many people did not know that he was absolutely up to date today, not speaking with anyone for 20 years. He was absolutely up to date to the last publications. And he told me, why you are so concerned, he told me, to have, to realize my solution, because Gödel's solution has a closed time-light curve that you can go in the future and then come back in the past in the universe. And I said, why are you so concerned? Because now we have the Kerr solution. And inside the Kerr solution, this is shown to be correct. There are closed time-light curves. This was the second very important message to him on which today I am thinking. Maybe we are inside a black hole. And maybe he was correct. And we are working with Roger Weda today on to check this fantastic possibility, that inside a black hole, our universe, we are building black holes, and therefore there is this fantastic, incredible situation. More and more black hole built inside black hole. What? This is all too beautiful to be an action of a dream. But then, 20 years since the paper he wrote for Einstein to our discussion, 20 years, he did not speak to anyone. I knew, however, that he was working on Spinoza philosophy, and he had found in the proof of the existence of God of Spinoza a new logical path to told me about. Therefore, before leaving the United States for something very unpleasant which happened, very, very, very unpleasant, maybe the most unpleasant thing in my life, I decided to leave Princeton. But before leaving, I had took a student with me in some of the meeting. And one day, this student asked him, Professor Weber, I took one of your book. Would you mind to sign? And again, I justify because Einstein used to say that asking an autograph is a last remnant of human being, of eating a person, or cannibalism. That person trying to have a signature is to cannibalize, to acquire knowledge, like a cannibal. Therefore, I said, I understand Einstein did not like this idea of signature, but you mind to sign this? And to my student who gave him a book, he said, yes, I'm happy to sign, but if you allow me, this book is two parts. One written by myself, he said, the Gödel proof, and an introduction by somebody else, which is very complicated. It's very long, but it's wrong. Therefore, if you don't mind, I will sign just my part of the book. And then I asked him, well, since you signed that and you gave me your reprints of your classic work, do you mind to sign this for me? When you will come to Pescara, you will see that on my apartment, that paper signed by Kurt Gödel. And then I asked him, can you give a lecture? Since you have been speaking to a student, in addition of me, I have a small class of 10 students. Would you mind, just before I leave for Europe, to come and to give a lecture to this? Monday, Wednesday, Friday, again, he smiled. And then he said, I would like very much to give a lecture to your student. And then, but I have not been working in relativity myself in the last 20 years. Then he waited, he said, in the last 20 years, I've been working on Spinoza. And I jumped because I said, oh, this is fantastic. And said, would you mind to give us a lecture? No, he said, in this case, I have been just working for the last 20 years. This was the end of this fantastic story. I explained to you why I understood finally I was very, very interested to come to Opava. And I found this idea now, science, that maybe Gödel could explain the Big Bang in an alternative way. It would not have happened if I were not going to come here for giving this lecture. But I was fascinated. Now I tell you something very, don't believe somebody asked me if I am religious. I am profoundly religious, but not in the traditional way. I am profoundly religious in the sense that Einstein spoke about ergot. And if you take the Einstein paper on special relativity, in the acknowledgement, there is an acknowledgement only to one person, Engineer Besso. The week before his death, this friend of Einstein, Besso, died. And Einstein wrote a beautiful handwritten letter to the wife of Besso. And he said, I will show you the letter when you come to Pescara. Einstein said, he preceded me a little bit, few short time. He was conscious he was going to die. But he wrote this letter by hand, beautiful. But he said, for us, in German, physicist believer, which is a different meaning. It's not believer, physicist believing in physics, in nature. You cannot translate in that sentence, for us, a physicist believing the present, the past, the future is just an illusion, although a very strong illusion. In that sense, I am religious. And today, before coming, I wanted to enjoy, to see as much as possible of this beautiful town. And I noticed yesterday afternoon a church, pink, very near the hotel. While the people were waiting for me to come here, I decided to run there. I repeat, I'm not a believer in the traditional sense, but I believe that everything I do has a meaning. Therefore, I rushed there and everything was closed, but I noticed one door was not closed, was almost closed. I opened the door, and in the back, there was a Franciscan monk, just after the door. And I said, what is this place? It's a monastery. A monastery. Maybe I can visit the church. Yes. And then we went inside. We took a picture. I can send you the pictures. We went inside. This beautiful, fantastic church. And there was a portrait of John Paul II. And I told him, we had very few minutes because I had to rush here. I said, you see, that has been a very good friend of mine. I will show you the picture of me with John Paul. And then he told me, sono, in Italian, sono il parroco. This was a fantastic meeting, emotional, because it was a contact and the meaning. And then the most profound meaning, I was looking usually a church as a saint, St. John, St. Mark. And then he smiled. He did not know that he was going to say something very important. Questa è la Chiesa dello Spirito Santo. Well, on this I would like to close, because my son told me one day, and I believe in my son more deeply than in anybody else, because he has my DNA, and he can see more than me. He said, Papa, you have been doing physics, but you forget that there is something else. What is something else, Jacopo? Tell me. Is the soul, the soul. But what do you mean, the soul? Yes, he told me. There is something else. It's a soul which is pervading in the universe, in which everybody of us give a small contribution. But this contribution, I said, go on, please, tell me more. Yes, each one of us, with science, enlarge the soul of the universe. And everyone go and give a contribution to that soul in his proper life. This is the most profound view I ever heard. And I'm convinced is correct, which this Franciscan monk told lo Spirito Santo. But this is just one way to materialize this idea. At this stage, you gave me an opportunity to tell really what I think. And this comes back to Opava. I asked the monk there, you know Mendel? He said, no. No, I said, but you know about Mendel. He did not know. He did not know that was like him in this region, in a garden of a church, not in an accelerator, big, complicated telescope or whatever, just having the joy of looking peace, reproducing peace in this small garden. Mendel discovered biology. Again here, very close to Opava. Maybe you should go back and film the garden. Mendel started here, biology. And then biology expanded all over the world under very different political and stressful conditions at times. Maybe you remember that one of the biologists more famous has been Konrad Lorenz. Well, he worked in Nazi Germany. There also, one of the most profound thinkers during Nazi Germany, founder of quantum mechanics, of Pascual Jordan, and I had the privilege to work as my first postdoc was given to me by Pascual Jordan, but this will be a different story. But it's related to this, because Pascual Jordan introduced the study of quantum mechanics in biology, but this will be a different chapter which we are still developing. But let's go back a moment to the history. Mendel, Lorenz. In Soviet Union, there was one of the greatest biologists Vavilov. But if you go in the late 30 years, in the last part before the war and during the war, you see that biology in Soviet Union disappeared. You can read in the book, beautiful book, by My World Line, by George Gamow, this tragic period in Soviet Union, written with elegance and with smile. That is the most beautiful part of the book of George Gamow. He said, there is traditional biology, the one of Mendel. But then in Soviet Union, Comrade Lysienko came in and purport that the ambience generate the change in the species. And he joked about, he said, you know, he said, it's interesting because if you have that a boy, John, look like his father, Peter, that is traditional biology. Mendel. But if you find that John does not look like his father, but looks like Jack the milkman, that is an example of how the ambience can modify the species. Well, we laugh. He was laughing. But really, sending Vavilov in a gulag destroy biology. And biology never took back in Soviet Union or in Russia still. I am sad today, but at the same time hopeful. In the most advanced country, and I don't, you know, all this on my scientific publication, there is a tremendous accident. Is the one about gravitational wave and Professor Kip Thorne. What Kip Thorne has been done in US is much worse than what, or equally worse, than what happened in Soviet Union with the case which I just mentioned, of Comrade Lysienko. The problem is that is much sad because this happened today in what is considered the most advanced democratic country. I am sad. I'm sad because this country, which like to make America great, is really endangering the planet and is endangering survival. And this happened in the country which should defend scientific knowledge. We have the greatest disaster since Galileo. I have expressed that. And that is the most sad part of the story. We all left United States. Me, Thibaut Damour, all the young people working with us, even Bekenstein, even Christodoulou, left. Now they are left alone with a person who wants to create walls, who want to attack, absence of respect, violence, the same violence that they told me in an incredible sentence. He said, in Southern California, we have a lot of grapes, but we cannot harvest them. To harvest, we need the help of foreign workers from Mexico, from other countries. And then the most incredible sentence came. You Europeans are the migrant workers of science. And this was too much. I answered immediately. I said, this country, without Fermi, without Bruno Rossi, without Riccardo Giacconi, without, and then I went on and on. And then I said, without Wigner, and without, of course, I was polite enough not to mention Einstein, but without this European, will never be this country. And then I said, I'm sorry. Not sorry for myself. I'm sorry for you that you are thinking in this way. But anyway, I said, let's cheer up. This was a good year. We had a lot of grapes. The world is changing. I explained already why I came here. I felt I had to. This confidence of coming here was paid in emotion and in view. This fantastic building of the beginning of the last century, which you still have there at a time when, even before the Bauhaus, and you should take picture of that building, is a fantastic experience, a fantastic beauty. The town is beautiful, but what is more important, you find scientists committed, on the right path, and a minority, an absolute minority. When we were in Princeton and we started the black hole, we were 6, possibly 7 people. Well, now there are a publication with 1,500 names on, saying things about pulsars and gravitational wave from pulsar. They neglect to mention my first paper in my first career, in which I show with few lines that the Crab Nebula could not emit gravitational wave. Here there are 1,500 people purporting with this instrument, incredibly complicated but trivial, that they found the same thing, but they forgot to say, it reminds me the accident when the NASA studied a special pen to write in space. And the Russian, of course, they did not invent a ballpoint pen working 0 gravity. They just use a normal pen of wood. I mean, you don't need that. You understand? And they did not mention my paper, because it's already there. It's a tragedy. The hope is that in this nonsense, which is taking money, millions of dollars publicity and all this, okay, here is a center which is honest. Not only honest, but pointing with Professor Stuklish to the very advanced topic, neck to neck with us. Therefore, I'm planning to collaborate with them, and I was very happy to see that the Italian ambassador felt very strongly about the agreement we have signed and asked to be kept informed continuously about our developments. We will do that, and we will exchange, and some of my former students are here, teaching here. Therefore, it's a fantastic possibility in this cradle of Middle Europe to have, I hope, a center of ICRANet, extraterritorial, tax exempt, but like all the embassy, like CERN, and to have the opportunity for here to link with the other centers, the one we are opening in Minsk, the one in Armenia, the one we are planning in Kazakhstan, in Uzbekistan, to create a new ambience in this Central Europe and Asia. And we are going to start the Ulugh meeting in a time in which Samarkand used to be the center of astronomy in the world, in a very enlightened world which create at the time the poems of not only a great astronomer, but also a great poet. We need poetry, we need thinking, we need serenity. Your other question was what I expect. I know that every action I did in my life, I am using all the thing of my life to make this last step. And I think we are approaching maybe the idea that Kurt Gödel was possibly correct. We are seeing from the first time a GRB 1901-14C, the strongest system in the universe, emitting JEV radiation. But what we have discovered, and now Holger Weda is speaking, is that this object, which is 10 billion light years away, after 40 years of work, we have been able to understand the moment of formation of the black hole. And we are seeing the black hole starting after a few seconds to operate. It operates extremely beautiful and complicated, the most difficult system ever studied by man. The atomic bomb of Enrico Fermi is a joke in comparison, for simplicity. An atomic bomb, a hydrogen bomb, start to be more interesting, but this system is much more powerful. CERN accelerates a few grams of protons and electrons at gamma 100, Lorentz gamma factor 100, at JEV radiation. But here we have a fantastic production of JEV radiation. 10 to the 30 times. Big, 10 to the 30. What means 10 to the 30? 10 to the 2 means 100. 10 to the 3 means 1,000. 10 to the 30 times larger than what is done in the laboratory at CERN and in the planet Earth. They are toy machines. Now we have to harvest, and the machine has been an intuition which we had based on the 6th student in Princeton work. And interesting enough, one of the few centers who understood this is Opava and Stocklish. Therefore, we are just at the beginning of a new era. But this new era happens at a time, this discovery we made, after my 40 years of visit to China. I went to China the 17th of May of 40 years ago. I was one of the first Western scientists to be invited in the communist Maoist China. In the beginning, I was mentioning to them why democracy was very important. I even wrote a book which was translated by the billion in China with Fang Lijie. I published many books in China. My art, you ask, is partly in China. I admire them. I admire especially one person in China who founded, are you there? A person. Europe made a lot of mistakes, of course. One greatest mistake was what happened with the German engineer, von Karman. Von Karman went to United States and created a small group. One group working with von Karman stay in Germany, von Braun, who then later went to the US. But with him at Caltech, he found JPL. And in JPL, there was a Chinese professor who declared to be interested in the Mao Revolution. The American did a big mistake. The German made a big mistake in losing von Karman. Goebbels sent a letter to von Karman saying, please come back. There will be no problem for you in Germany. Von Karman answered with this picture profile. And he said, are you sure that nothing will happen to me if I go back to Germany with this picture? I just gave a lecture in the anniversary of my 40 years in China. And I put this picture of von Karman with his nose. And one of his best students was Chen Cheng-Chen, who wanted to go back to China, but the Americans did not allow him. They kept him under house arrest for 5 years before relieving him in exchange of an American soldier in Korea. And after that, he went back to China. He made the A-bomb, the H-bomb, the Long March rocket. Chinese work not in the same freedom, but constantly, with a lot of work. They succeeded economically more than freedom. They succeeded in everything. They're building universities all over. I want to help them. I've been helping them for 40 years. Why I help them? Because in the best tradition of this church that you have here, like Matteo Ricci, they need intellectual support to be free and to add to success and economy also the respect of human being. And this is the thing I am working now very much.